In this video, we're going to start looking at statistics, population, sample, and data. So we're going to learn how to take data and visualize it in a certain different ways. We're going to talk about frequency distributions and diagrams, histograms, and pie charts. So first, let's talk about statistics in general. Statistics is the science of collecting, organizing, and summarizing data in such a way that valid conclusions and meaningful predictions can be drawn. The population is the set of all objects in a study. And everything we're going to be talking about is akin to set theory. So the population is what we call our universal set U. It's everything that we're talking about. Could be all people in the world. It could be all people in the United States, or it could be something like all objects in a certain room or something. A sample is any subset of that population. Each of the elements of the set of the data collected from a sample is called a data point. So we look at the entire population and we take just a subset of it, just a small part of it, and then we look at something for each part, and those are called the data points. So note that what's the point of having the population in the sample? Gathering data from a population, from every person in a population, is often not feasible. So instead we gather data just from a sample of the population and then make a meaningful claim about the entire population. So for instance, if you want to see some kind of data of some product that you're creating, you're not going to check the weight or whatever of each and every single product that comes off the factory line. That would just be way too much work. So instead you look at a subset, just some of them, to make a conclusion about all of them. So one way to organize the data collected from a sample is to create a frequency distribution. This is a table which lists each data point and how many times it occurs, its frequency. The relative frequency of a data point is the frequency expressed as a percentage of the total number of data points. And we'll see an example of that on the next page. So here, our first example, while bargaining for a new contract, employees asked their employers to provide daycare services as an employee benefit. The personnel files of each of the 50 employees at the company were examined to see how many children under 6 years of age an employee was caring for. And note that what we're talking about is this 50 employees is the entire population that we are concerned about. So here we're not actually taking a sample, a subset, we're just looking at the entire population. And all of those number of children that employees have was given in this little thing of data here, array of data. And it's not organized in any really particular way, it's just given the data. So we can think about how can we organize this information? Well, we could, kind of group different things together. In fact, let's group all the stuff that have the same. Let's count how many zeros, ones, twos, threes, fours, and fives we have. And that's what the frequency distribution is. So here we're going to list our number of children under age 6, that's our 0 through 5. And then we're going to count how many of each of those are. So there are 16 zeros in this array. There are 18 ones, 9 twos, 4 threes, 2 fours, and 1 5. The relative frequency is going to be how many there are compared to the total. What's the percentage of the data that are zeros? So we look at the total number of data points, that's the 50, and we look at the percentage of each. So 16 divided by 50, 18 divided by 50, on and on and on. And we can express that as a decimal. So 16 over 50 is 0.32. And then, of course, we can think about that as a percentage, 32%. And note that if we added all the percentages together, we would get 100%. So we're going to focus mainly on this second kind of column here. That's what we're going to look at most. Our relative frequency is a number between 0 and 1. You can think about it as the probability that a number in this data set is going to be a 0, for instance, for the 32%. So then the point of having that information is really to visualize it in some way. And yeah, the chart is helpful, but it's even better to have some kind of visual data. So here we're going to use a bar chart to organize the information. The x-axis here, the bottom horizontal axis, is the number of children under 6 years old. We can see our categories here are 0 through 5. And then the heights are going to be not the frequency, but the relative frequency. And the reason we want to do that is because it's easier to compare to something else with the relative frequency. So here we said that 0 was a 32% of the population, and we can see that it corresponds to a 0.32 on the relative frequency. And that's the same for all these. Let's go back and see we had a 8% for 4. For 4. Oh, sorry, 4% for 4. That's better. And that corresponds to a 0.04 on the relative frequency, and for all of them. All right, and now with this visual, we can kind of clearly see that most of the employees have 0 or 1 or 2 children, and then not a whole lot have 3, 4, and 5. So that previous example is a nice introductory example because there were only 6 possible data points. However, for many examples, we're going to have a lot more data points. It's not just going to be 6, and it could vary greatly. In fact, it could be a continuous kind of thing. So what we're often going to do is we're going to group the data into a manageable number of groups. And that's usually going to mean 4 to 8 different groups, and then repeat this process. So let's look at another example. An instructor for an acting class offered through a local arts academy is open to anyone at least 16 years of age. 42 people are enrolled. Their ages are as followed. And note that this 42 corresponds to the population, the 42 people. And we have all those ages, not given in any particular order. So we want to group this data into a manageable number of groups. So we're going to usually use 4 to 8 for no particular reason. We're going to group these into 6 groups. We could have chosen anything, but just we have to choose some number, so we're going to choose 6. So a way that we can do this is we can look at the range of the data. Range is going to be the maximum value minus the minimum value. So we take the largest value, which is 62 in that group, and subtract the smallest, which is 16. And we have a range of 46 years. So if we want 6 groups, we could take the 46 and divide by 6, and that would give us a 7.666, which isn't a very nice number, so we're going to round up to 8. I do want to make clear that if you're ever going to do this, you always have to round up, otherwise you're going to lose pieces of information. For instance, if we rounded down to 7, and we had our 6 groups, we wouldn't include the 62. In fact, I think we would lose the 60 as well and some other data points. So we have 6 equal groups that are each going to consist of 8 years. And we got the 8 from taking the range, dividing it by 6, and then rounding up to a nice number. So now that we have that basis, now we can create our frequency distribution. So we have our 6 groups, each have a width of 8. So 16 to 24, 24 to 32, 32 to 40, 40 to 48, 48, 56, 56, 64. So note that since we rounded up, the last value here, 64, is bigger than our biggest value in our distribution, which is 62. But if we rounded down, the biggest value here would be less, and that would not be okay. So let's talk a second about this 16 to 24. Note that this less than or equal to thing makes a difference. Why do we have it like this? Why less than or equal to and then less than? The next one, 24 less than or equal to less than 32. Let's think about a question. Which group does 24 belong to? And here, because we have the less than or equal to 24 in a second group and just less than in the 24, then it is the second group that it belongs. But note that if we didn't have that distinction, less than or equal to and less than, then 24 could belong to both groups or neither groups. So we need to kind of have this less than or equal to less than sort of way to divide the group. So we're always going to do it in that form. So that's what that means. That's to distinguish between the borderline ages. Where do they belong? Which group? It's always going to be that less than or equal to less than format. Either way, we get our frequency, 11, 13, 7, 3, 2, 6. The total is not 50, but 42. The relative frequency is going to take that number divided by a total, divided by 42. And that gives us a decimal form of our percentage. Note if we added all those up, we'd get 1 or 100%. And we can look at this as the ages in this histogram. And this is what we call a histogram. So let's talk about some properties of this histogram real quick. Note that we have our ages on the bottom, just like we had before. But now all of our bars are touching. We're going to need that because this is a number line down here. It's like we have from 16 all the way to 64. And it's just a number line, and then we're taking that number line and dividing it into 6 chunks, 6 groups. The way that it's labeled in this histogram is just labeling those different groups of 16, 24, 24 to 32. But what we're really doing is taking a number line and dividing it into 6 equal parts. So then, just as we had before, the relative frequency is on the left. And then if we think about the ages of, let's say, people 24 to 32, we have that this represents 31% of the data. And if we think about all the shaded boxes here, that box is 31% of the area that we have there. Right? We look at this 31.31 on top of the chart, on top of the bar sometimes. Note that when we have a histogram, we have our title as well, which is important. And we have our labels for our axes. And we're always going to have that information in all the histograms. It's important to label kind of everything. All right, so let's think about this in general. How do we create a histogram? So you have this little step-by-step process we can follow. If the raw data consists of many different values, we create intervals and work with grouped data. If not, we list each distinct data point. In our first example, we just listed each distinct data point. In the second example, we created groups, and we usually do 4 to 8 groups. Then we count the number of data points in each interval, or the number of each individual data points. And we list the frequency of each. That's kind of doing the same thing. The number of data points is the frequency here. Then we find the relative frequency by dividing the number by the total number of data points. And the resulting decimal can be expressed as a percent. And then we create our histogram from that using our boxes and using our relative frequencies. We're always going to have relative frequency on the left, or the vertical axis. And then we're going to have our groups on the horizontal axis. So let's look at this in one more example. To study the output of a machine that fills bags with corn chips, a quality control engineer randomly selects and weighs a sample of 200 bags of chips. The frequency distribution is given below. Construct a histogram of the bags of corn chips. So here, we've already gone past the work of creating the frequency distribution, in fact, the relative frequency distribution. Note, how do we get this relative frequency? This is taken by doing 10 divided by the total number of chips, bags of chips. And note that here is a good example of the population and sample. This 200 bags of chips, that's not the population, that's just a sample. The actual population is all bags of chips that this machine fills with, or the bags that fills chips. That's a lot more than 200. We're just using the 200 as a sample of this. So we take the number of bags, we divide by 200 to get the relative frequency here. Note that if you added all these together, you get 200. If you added all these together, you get a 1. And here we have 7 groups. They're all even. They're all of width 0.02. Sorry, 0.2, not 0.02. 15.3 to 15.5 is 0.2. And we have that for each of these. So now we can create a histogram of these bags of chips. So we're going to have 7 different groups on the bottom, relative frequency on the side, and the corresponding heights of those bars. So again, we think about from 15.5 to 15.7. That bar corresponds to the 12%. That's 12% of the area total is in that bar. So note that something special that happens with this histogram is the shape is going to be really important. And in fact, this is what we're going to be calling a normal distribution. And we'll talk about that in a few videos. It'll be the last topic that we talk about in this course, the normal distribution. The fact that it's got the center bar there is really big, and then it goes and trails off in either direction. It's a nice symmetric kind of shape. So looking at one other way to visualize data, we can think about a pie chart. And this is going to be very useful in dealing with categorical data, where we're looking at parts of a whole. That's the idea of relative frequency. So the difference here between what we did before is before we didn't really have categorical data, we had quantitative data. We had, our groups were associated with numbers. Now our groups are going to be associated with some kind of category. So looking at an example, the different types of degrees, the number of each degree conferred in the US in the 2010-2011 school year is given below. So note that our groups are not numbers. It's not 15.3 to 15.5. That's quantitative data. This is categorical data, qualitative data, where we're actually just giving just names. It's just some kind of word, some category to each group. But we still have our frequency and relative frequency. We know that there were 942 associate's degrees given in that school year. We think about the total number is just going to be adding up all of these values. And that's going to come out to be, so total, if we add all these together, it's going to be 3,533. This is given in thousands. Degree, and we can find the relative frequency by doing 942 divided by our total to get that 0.265. We can find the rest by dividing by taking the corresponding frequencies, dividing by 3,533. So then our pie chart is going to be looking at the circle as a whole, right? That represents 100%. We're going to divide off little chunks of it to show the different percentages here. So we think about our bachelor's degree had 48.3%. We've labeled that here, and that represents 48.3% of the area, almost 50% of the circle. The master's degree is 20.6%. Labeled that here, and that's going to be about 20% of the circle, 20.6% of the circle. We could go on and on there, right? The doctorate is 4.6%. Label that there. That's going to be just a 4.6% of the circle. And the pie chart is a nice way to sort of visualize the parts of a whole. But to do it when we only have categorical data, a histogram would not work well here because the bottom would not be numbers, and that's what we kind of need for a histogram. We could do a bar chart, that's fine, but it's nice to do a pie chart as well. So now that we have some kind of ways to visualize data, now we can start talking about analyzing the data that we're given. Right now we can kind of visualize it in some way, we can organize it in some way. Next, we're going to try to make some kind of conclusions about the data. We're going to look at the center of the data and the spread of the data. That's the two kind of ways we're going to analyze the data in this course.